Today's lesson is about projectiles, which is one of the parts of the mechanics course that most people find the most difficult. What the specification says is that you must understand how to make use of the independence of vertical and horizontal motion of a projectile moving freely under gravity, and that is specification point 15 if you're taking A-level and 7 if you're taking international A-level. So let's see what this means. What does this independence of vertical and horizontal motion mean? It means if you take a cannon like this on the top of a cliff and you shoot a ball out of the cannon with a horizontal velocity and you drop another cannonball at the same time, then they're going to hit the ground at exactly the same moment. The horizontal velocity has no effect on the time that it takes to fall. This is what it means by independent. It is exactly the same motion vertically, whether or not you give it horizontal. So the vertical motion is independent of the horizontal motion. As the name projectiles implies, what we're going to be dealing with mostly are objects that are projected at an angle. They travel in an arc like this and then fall back down again. And so step one for all of these should always be calculating the vertical and horizontal components of this velocity that the object is projected at. And of course, if you're going to calculate the vertical component of this velocity that it's projected at, the vertical velocity is going to be v, that value of the hypotenuse, that value that you're given for the speed at which the projectile is shot at, is going to be v sine theta. Our horizontal velocity will be v cos theta. So it is worth taking the time at the start of all projectiles questions to just go ahead, make that your initial step. You need to have the vertical velocity and the horizontal velocity at some point during the question, so just get it done. Projectiles questions can be divided up into levels of difficulty. We're going to start with level 1, and I'll talk you through all the different levels as we go through. So level 1 is our cannonball. The cliff height plus the height of the cannon is 16 meters. So when you just have a projectile projected from a height and it falls down to the ground, 16 meters is our vertical displacement. Our horizontal velocity is 125 meters per second. And it is useful to label these things as you encounter the question because it allows you to build up your SUVAT quantities. And how far away from the cliff will it land? We want this distance here, which is our horizontal displacement. It tells us to assume no air resistance. Usually the questions will say that. Even if they don't say that, unless you're told directly that there is air resistance, you should always just assume that there is not. Some things you should realize here is that when the cannonball is shot or dropped, its initial vertical velocity is 0. And I'm going to change this up here and call that UH. It's going to be the same in any case, but just for consistency. It does have a vertical acceleration, because all falling things have a vertical acceleration, and our specification mentioned falling freely under gravity. So 9.81 meters per second squared is our vertical acceleration. And it has no horizontal acceleration, because we have no air resistance, and therefore no resultant force acting horizontally. The key part about this is that the time that it takes to fall from this point up here, which is our drop point, and we're focusing on the red arrow here, but in terms of vertically, that is the same as the blue. So the time it takes to land depends only here on the height. The acceleration due to gravity is constant, so how high the ball is when you drop it. The horizontal distance it travels, of course, depends upon that time. The time that is in the air for, because we know distance is speed times time. So we're going to take that time and multiply it by the horizontal speed to find the horizontal distance. So the key here is always to find the time that the object is in the air for. And that is the only thing that the horizontal and vertical components have in common. So let's go ahead and find that time. And this will be step 2. Step 2 is always going to be using your SUVAT equations to find out how long the object is in the air for. And so let's make a little list of what we have for SUVAT. We have 16 meters is our vertical displacement. We have an initial vertical velocity of 0 meters per second. We have a vertical acceleration of 9.81 meters per second squared. And what we're after is time. And if we look at these, we will quickly see, I hope, that the equation we should use is S is equal to ut plus a half at squared. And if we put the numbers in handily, our first expression becomes 0. That will give us a t squared of 15 over 4.905. And finally, a t of 1.81 seconds. This is our key. In this problem, our final step, and a lot of problems are going to ask you to find the horizontal distance or the range of the projectile. Step 3 then will be use that time and the horizontal velocity to find the distance that the object travels. So we'll keep using displacement here. Our horizontal displacement is going to be our horizontal velocity times this time that it spends in the air. So 125 times our 1.81, and that's going to be 225.7, which is 226 meters. And there is our answer. We can use this expression here, which is just displacement equals speed times time, because there is no horizontal acceleration, and so we do not need to use SUVAT expressions. Level 2 questions involve the entire arc, so it goes from the ground up into the air and down again. Our first level 1 was just this right-hand side half of it, and so now we're adding in an extra element to it, making it level 2. So again, we're going to follow our steps. Step 1, we said, was find the horizontal and vertical components. We know that the speed at which the ball leaves the foot is 17.8 meters per second. And we know that we have an angle of 52 to the horizontal. That's that there. So once we've got that information, we can go ahead and calculate our vertical and horizontal components. I will calculate them here, speed it up, and you can check your answer at the end. Do pause the video if you want to have some time to calculate. Okay, the question doesn't directly tell us to do that, but we know that's going to be our step 1. If at all possible, that is what you were doing, because most projectiles questions you are going to need both of those. Okay, what we're actually trying to find is our horizontal distance. So the same question as before, we need to know the range that this kick goes for. And again, step 2 is finding the time in the air. This one is a little more complicated because it goes up and comes back down again. So what we're going to do is we're going to divide this, just like I did with the green line, into part A and part B. And we're going to find how long it takes to go up to the peak of its motion, and it will take exactly the same time to come back down again. So we're going to concentrate on finding the time for A, and then just multiply it by 2. And we start making a list of our SUVAT. You don't have to do this all the time. Initially, it's a good idea. After a while, you might get faster and faster and faster at doing these, and this becomes unnecessary. But to start off, it's a good idea. You do need to be careful with the sign that you assign to these numbers. Now, I've given our UV a positive value of 14.3. But because our acceleration is in the opposite direction, then it has to have the opposite sign. So I can do one of two things. I can either assign our initial velocity minus because it's going upwards, and conventionally that would be correct, and therefore I give our acceleration a positive value because it's downwards, or you can do the opposite. As long as they have a different sign because they're in a different direction, it will work. We're looking for the time. Now, apparently we don't really have enough information here. But what you have to remember is when the ball goes up along this arc here, it is the same as a ball going up and coming back down again in terms of the vertical motion. So actually just up at the top of the arc here, vertically, it stops momentarily. So our vertical final velocity for this calculation is going to be 0. And that makes a huge difference to us. Now we look at these numbers and we think, what Suvat equation am I going to use for this? And it's going to be v is equal to u plus 8v. And so again, I'll do the calculation, speed it up a little. You can pause the video and do your own calculation and compare answers at the end. Okay, so we get an answer of 1.43 seconds. Let's remember that is only for half of the motion, that's for section A. We now have to multiply that by 2 to find the total time that the ball is in the air for. Now we have the time. It's a very simple calculation, and we're assuming with no air resistance. Very simple calculation to find the horizontal displacement. And there we have it. That is level 2. Level 3 mixes things up a little bit. And although it might not be technically more difficult, because you're asked to do it slightly backwards, and because you're not given a diagram, and there's a little bit of extra information in it, I've assigned this as level 3. So we have a bullet coming out of the barrel of a rifle. That is the length of the rifle, and that is the acceleration of the bullet in the barrel. How far will it drop if it hits a target 200 meters away? My advice is, if you're not given a diagram, draw yourself a little diagram so that you can mark in all the information that you're given, and so it makes it clearer for you. So if this is the barrel of the rifle, it's 1.2 meters long, and our acceleration is 20,000 meters per second squared. This is what happens to the bullet when it comes out. That is the target, and we know the distance to the target is 200 meters. We are after this, the vertical displacement. First thing we need to know is how fast does it come out of the barrel at? So that's our sort of additional little calculation that they're asking us to do here. We know that it's traveling for 1.2 meters and at that acceleration, and we can assume that the initial velocity is 0 inside the barrel. And so we want the final velocity as it comes out. We have u, we want v, we have s, and we have a. So we're going to go ahead and go v squared is equal to u squared plus 2as. Again, pause the video, and you can check your answer after. I will speed up this section so you can see the calculation fast. This now becomes our horizontal velocity for the actual projectile. We know also that its vertical initial velocity is going to be 0. We know that its vertical acceleration is going to be 9.81. We want the time that it's in the air because that's our next step. However, we do not have what we had before, which was the vertical displacement. So we need to look at an alternative way of finding the time in the air. Again, we're assuming no air resistance, so our alternative way, it's flipped on its head, this one. We are going to use the horizontal distance that we know it's traveled and the horizontal speed that we know it has to find the time that it takes to travel this distance. And that will be the same amount of time that it's in the air for. And so we're going to do it backwards, if you like. I would recommend that you keep this time in your calculator. Examiners in general recommend that you do that. If at all possible, you might give your answer to a rounded two significant figures like here, but keep it in the calculator if you know you're going to be using it again later. Now, let's see what we have. We have our initial vertical velocity of being 0. We have our vertical acceleration as 9.81. We don't know our vertical displacement, that's what we're after. But we do know our time, which is 0.91 and change seconds. So we need to find a Suvat equation that is going to use all of these. That equation is S is equal to ut plus a half at squared. Again, pause, calculate. I'll speed up this section showing the calculation. You can check your answer. And there you have it. If you were aiming for something with this bullet, you'd have to make sure that you compensated for 4.09 meters that the bullet was going to fall while it's in the air. Level 4 problem is again a little bit of combination and extension, and I'm going to use an exam question to illustrate this for you. It's an athlete at a long jump. It gives us his initial horizontal and vertical speed. So they've done step 1 for us, so that they don't have to assign marks essentially for you're doing that. But we want to show that the total time the athlete spends in the air is about 0.6 seconds. And we'll note down here, assume his center of gravity is at the same height at takeoff and landing. We've always assumed that before, and that sort of gives us a clue that maybe they're about to complicate things later on. But again, we have a picture here that is of very little use to us. So what we're going to do is draw ourselves a little diagram. There's our horizontal speed and there's our vertical speed. And our athlete is going to go like this. So this is very similar to the footballer question that we had before. We're going to find the time that it takes to go from here up using the vertical speed and then multiply that time by 2 to find the total time that it takes this arc. So again, I'm going to do the calculation, speed it up. You have a go and come back when you think you're ready. You will notice in this that I switched around the signs in this case. I assigned his initial vertical velocity to be a positive and therefore had to put the acceleration, because it's in the opposite direction, as a negative. The other thing you might notice is the layout of the work. It is very important. It isn't essential, but it is very important that your work is clear and that an examiner understands what it is exactly that you are doing. And so it is a good idea to get into the habit of laying out your work in a very orderly manner so that it can be followed very easily. And finally, because they asked us to show that it's about 0.6 seconds, you must give at least one more significant figure than 0.6 in your calculated answer. And it's always a good idea to put in which is approximately equal to, like I did here, approximately equal to 0.6, just to finish it all off. The next part of this question is, like we said, the normal sort. Calculate the horizontal distance jumped by the athlete, so we know we're going to go distance equals speed times time. They gave us the horizontal speed, which was 8 meters per second. And we have the time up here. You can use 0.6. It's not incorrect to do that. But again, best practice is that you use your calculated value. Better still, keep whatever value you had in your calculator and use it in the next one. This gives us an answer of 4.57 meters. Okay, relatively straightforward so far. This is where the level 4 bit comes in. In reality, when the athlete lands, his center of gravity is 15 centimeters lower. What extra horizontal distance does this give him? Again, let's have a little diagram so that we can see what we're dealing with here. slightly exaggerated in terms of the scale, but that is 0.5 meters. We all know that is 8 meters per second is the horizontal and 2.8 is the vertical. If he launches at 2.8, when he comes back down through this point on the way down, he'll be going at 2.8 again. And of course, still at 8 horizontally, because we have no air resistance. We're not talking reality here, we're talking the ideal situation. Okay, so now what do? We need, like always, the extra time that this athlete is in the air for. So we need to look at this data and say, okay, how are we going to find the extra time? Well, this becomes our vertical displacement. We know what our initial velocity for this little block here. This is the block of interest to us. We know our initial vertical velocity for that is 2.8. We know our acceleration. So let's just start making our little list. You will note they both have the same sign this time because they're now both in the same direction. Our vertical displacement is 0.5 and we're after our time. Once you make that list, you should think, okay, we're going to use S equals ut plus a half at squared. We can certainly do that. You may see a complication with this, which perhaps is not a complication, but let's go ahead and do that and see what we end up with. 0.5 then is equal to 2.8t plus 4.905 t squared. And of course that becomes 4.905 t squared plus 2.8t minus 0.5 is equal to 0. And we'd have to solve that. And maybe you're perfectly comfortable solving that. Calculators will do it for you. I'm going to do it a second way, so everybody, even if you're not comfortable with this, you can also do this kind of question. It's 2 stages, but it may make life a little bit easier for you. So that's method A. Method B is to say, okay, well, if he's falling for 0.5 meters, we want to find out what his final vertical velocity is. So he comes through this point at 2.8 meters per second and falls for half a meter more, and he'll have a final vertical velocity. So we're going to go v squared equals u squared plus 2as Now, once we have that, we have our VV and this information, and we can use a second Suvat equation to find out what our T would be. So the most straightforward one is V is equal to U plus AT. So our 4.2 is equal to 2.8 plus 9.81 T, giving us a T of 0.143 seconds. So that's the extra time that he spent in the air up here in this green triangular bit. We want the horizontal distance, and as ever, our horizontal distance is going to be our horizontal speed times this time. So our extra horizontal distance is 8 meters per second times 0.143, giving us 1.14 meters. This is exactly the reason why long jumpers jump the way they do. They take off and then they pull their body up so they've got extra distance to fall. That's it for our projectiles levels. That's about as difficult as they get. Let's spend a moment reviewing the steps. Step 1, find your vertical and horizontal velocity. You're given the speed, usually, that the projectile is shot at. You need to find the vertical and horizontal components. Step 2, time is the key. Find how long the projectile is in the air for. And then that is what the two motions have in common. Step 3, use that time to find the horizontal distance traveled using the horizontal speed.